Welcome to Algebra 1, Lesson 7-4, Unit 8, Applications of Linear Equations. I work out of Pearson Algebra 1, copyright 2009. Our objective is today, I will be able to solve problems with systems of equations. We've been working on how to solve systems of equations. Now we're going to look at how to write a systems of equations and solve it. What it really boils down to a lot of times is a simple thing that I like to say, part plus part is equal to whole. There are some very specific problems we're going to look at today, but I believe 3 out of the 4 examples today are really related to this part plus part is equal to whole relationship. So let's see how we can solve systems of inequalities or systems of equations using this part plus part is equal to whole relationship. Example 1t, we have a classic solution mixture problem. Let's read it first. A chemist has one solution that is 50% acid. She has another solution that is 25% acid. How many liters of each type of acid solution should she combine to get 10 liters of a 40% acid solution? This problem comes down to a part plus part is equal to whole relationship. You should write that down. This is a part plus part is equal to whole relationship. This is similar to what we're going to see a little later on, a coin problem. It's a mixture problem also. So this part that we're going to be worrying about, well, before we get into the equations, we should really define some variables. So let's do that over here. We'll just say x is equal to the number of liters of, put of there twice, number of liters of 50% solution or 50% acid solution. And then we'll say y is equal to the number of liters of 25% solution. What you got to understand, what you got to wrap your mind around here is that we're going to mix something that's 50% with something that's 25%, and what we want it to end up being is 40%. So we're mixing two different solutions, one 50%, one 25%, and then we want to put it together as our whole to get our 40%. So the first equation that we're going to write is going to be related to the whole, how many actual liters? Well, x is the number of 50% solution plus y, the number of liters of 25% solution. And this equation relates how many liters of the solution we have, which is 10. The next equation that we're going to get is we're going to take this number of liters and we're going to multiply it by its percentage. 50% as a decimal, remember, is 0.5. So our second equation comes from this idea that we're going to take this and multiply it by the percentage. 0.5 or 50% of how many liters of that plus, in this case, the decimal is 0.25. So it'd be 0.25 times y, and that is equal to this whole, the 10, times the percent, which is 0.4. Now I'm going to rewrite that. I'm going to write that a different way. I'm going to switch that around. I'm going to put the percent first, as I have been doing. 40% times how many liters we have. Now these are our two equations that we need to solve. This is our system of equations. This is our one equation, and this is our other equation. And what we're going to do, and I'm actually going to get into this solve portion. I've set up the equations. Now I need to solve them. And what I'm going to do to solve them, and I'm going to do this work in blue. I'm going to take this equation that only has the x and the y in it. I'm going to rewrite it over. X plus y is equal to 10. And I'm going to solve this equation for y by subtracting x from each side. When I do that, the x's on the left cancel, giving me y is equal to 10 minus x. Remember, I can't put these together. So the first equation solved for y is equal to 10 minus x. This amounts to a substitution problem. There's 3 ways to solve systems, and this is a substitution problem. So what I'm going to do now is I'm going to take this part, this 10 minus x, and I'm going to substitute it in for y into this equation. So I'm going to write this equation down, 0.5x plus 0.25. But instead of y, I'm going to put parentheses. And inside those parentheses, I'm going to put 10 minus x. And here I'll just do 0.4 times 10, which gives 4. 0.4 times 10 is 4. So now here's the equation I have to solve. Once I know this value of x here for solving this equation, you can see that right here. This is what I'm solving. To solve this, I have to distribute 0.25 to 10 and to minus x. When I do that, that gives 0.25 times 10, which gives 2.5. 2.5 times minus x is going to give me minus 0.25x, and then I copy everything else down. Bring the equals 4 down, the plus sign, and the 0.5x. At this point, I have to combine these two like terms. I actually just need to smush them together. I don't need to try to add or subtract them to these. I just need to put them together. I need to think 0.5x minus 0.25x. So I have to subtract 0.5 and 0.25. And when I do that, that gives 0.25x. I write down the plus 2.5 is equal to 4, just bringing everything else down. Now let me shift this over a little bit so I can just continue to line up my equal signs. Now it's a real simple equation that we need to solve. We just have to subtract 2.5 from each side. When we subtract 4 and 2.5, that gives us 1.5. And I bring down the 0.25x, and I divide each side by 0.25. When I do that division, x is equal to 1.5 divided by 0.25 is 6. So what that means, in terms of this problem, if we just scroll up actually we don't need to scroll up, it's right here. X is the number of liters of 50% acid. So there are going to be 6 liters of 50% acid. And then we need to add to that, well, 25% solution. If there's 6 liters and 10 liters total, we go 10, take away 6, and that would give us 4. So we'd have 4 liters of 25% acid solution. So my final answer here, I'm going to circle it, separate it a little bit, would be 6 liters of 50% acid solution and 4 liters of 25% acid solution. But the initial setup, which is the key thing, comes to a part plus part is equal to whole relationship. In example 2, we have another type of mixture problem. It's a coin mixture problem. We're told that Nikki has 12 coins worth $1.20. Some of the coins are nickels and some are quarters. I got this broken down into 3 simple steps. If you got any younger brothers or sisters or kids, for that matter, that watch Secret Agent O, so you know 3 simple steps. I try to keep things simple here, so let's take a look at this. Part A tells us to let Q equal the number of quarters and N equal the number of nickels, so they define the variable for us. What we need to do is write an equation relating the number of quarters and the number of nickels to the total number of coins. This is a classic part plus part equals whole problem. Let me explain it to you. First off, I think you should write down this. Part plus part is equal to whole. And in part A, we need to write an equation relating Q and N to how many coins there are. How many coins there are is our whole. This is our whole. We have 12 coins in total. And if we add Q to N, that'll give us 12. The number of quarters plus the number of nickels is equal to 12. Notice, I didn't just say Q and N that time. I said what they meant. The number of quarters plus the number of nickels is equal to 12. So this is our part A. Part A gives us our first equation. Part B, write an equation relating the value of quarters and the value of nickels to the total value of the coins. The total value of the coins is going to be our whole. Again, this is a whole here. And that's how much the coins are worth. The coins are worth $1.20. To write this side of the equation, we have to take the value of a quarter expressed as a decimal. The value of a quarter expressed as a decimal is 0.25. And we need to multiply that by how many quarters we have. So here we have 0.25 Q plus the value of a nickel. Now that's 0.05. A lot of kids make the mistake of putting 0.5 here. No, 0.5 would be a half of a dollar. Remember, a nickel is 0.05, so it'd be 0.05 N. Here's our second equation, and that's part B in our three simple steps. What part C is doing by asking this question, it's asking you to solve. So we need to solve this system of equations we wrote with step A and step B. How do we solve this? This is a classic substitution. We either solve the first equation for either Q or N. So the first thing I'm going to do is rewrite that down. I'm going to copy it down so I have Q plus N is equal to 12. Now I'm going to show my work, and I'm going to solve this particular equation for Q, and I'm going to solve it for Q by subtracting N from each side. What that gives me is that Q is equal to 12 minus N. So what I do then is I take the second equation here and I use it and I substitute 12 minus N for the Q. So I'm going to write that equation down, 0.25. Now instead of Q, I put parentheses and I put in that 12 minus N. Then I copy the rest of the equation down, plus 0.05 N is equal to 1.20 or $1.20. Now I solve this equation. I'm just going to bring this equation, I'm going to really just rewrite it up here so I have more room to solve it. It's 0.25 N parentheses 12 minus N. Now that shouldn't be an N there, it should just be 0.25. That should be just 0.25 there. Plus 0.05 N is equal to 1.20. Solving this equation, I have to distribute this 0.25. 0.25 times 12 is 3. 0.25 times minus N will give minus 0.25 N. I copy the rest of the equation down. That should be a 0 there, not a 5. 0.5 N equal to 1.20. Here I combine these two like terms, smush them together, I add them, negative 0.25 N plus 0.05 N. That gives me negative 0.2 or negative 0.20 N. I put the plus 3 equal to $1.20. I subtract 3 from each side. Don't make the mistake. You got to put that as 0.00 after the 3. And when I subtract this, $1.20 take away 3 would be a negative $1.80. On this side, these cancel out, bringing down the negative 0.20 N, and then dividing each side by negative 0.20. We get N to be equal to 9. The number of nickels is equal to 9. To find the number of quarters, it's going to be 12 minus 9, which is equal to 3. So the number of nickels is 9, and the number of quarters is 3. Of course, you could always do a guess and check, but if you're told to write a system of equations and solve, this is how you would do it. Example 3T. Opposite direction travel with wind. Suppose it takes you 7 hours to fly 2,800 miles from Miami, Florida to Seattle, Washington. At the same time, your friend flies from Seattle to Miami. His plane travels with the same average airspeed, but his flight only takes 5.6 hours. Find the average airspeed of the planes. Find the average wind speed. We have to find two answers here. We have to find the average airspeed of the planes and the average wind speed. Don't let that word average trick you out. Our answer will end up being the average airspeed, so no big deal there. Since we're talking about speed and distance traveled, you're going to want to remember the distance formula here. Distance is equal to rate times time. Now, what you got to understand is when we're talking about opposite direction travel with the wind, since we're talking about opposite direction travel, the distances traveled are the same, and we're going to have two equations here. We're going to have one equation for u, and you travel 2,800 miles. Now what we need to do is we need to find this rate. And we're going to multiply that by your time. You travel the 2,800 miles in 7 hours. We're going to fill this in, and notice I left some space in here. We're going to have to add or subtract something in here. Now, for your friend travels 2,800 miles, and the rate is going to be calculated differently, and he does that, the time, in 5.6 hours. So we're starting to set up our system of equations here. Now, the rate, that's what we're being asked to find. So that's going to be the area, the airspeed. That's the rate. So in this rate times time is equal to distance problem, we have to put a variable in for the rate. In this case, we're going to put in two variables. When you are traveling with the wind, now notice here I have a diagram. These three blue lines represent the wind, and here's an airplane. When you're traveling with the wind, your speed is increased by what's called a tailwind. That wind coming from behind increases the airplane's speed. Now, here, since it takes your friend less time, your friend is traveling with the wind. I'm not going to write that over here to the left of these equations. Your friend is traveling with the wind, or what's called a tailwind. If we turn that wind around, well, let's put that rate in there first. So since your friend's traveling with the wind, that's going to be the speed of the airplane plus the speed of the wind. When you're traveling with the wind, it increases the speed of your travel. If we turn that wind around, and you travel into the wind with the airplane, what that does is slows the airplane down. Even though it's traveling at 450 miles per hour, 460 miles per hour, you actually end up slowing down because of that wind. So what we have to do, we express that speed, that rate. This is what we're doing here. We take the speed of the airplane and we subtract away from it the speed of the wind, because you're going to be slowed down. Now here's the system of equations we need to solve this problem. Once we solve for A, we'll know the average airspeed of the planes, and then we'll be able to go back and find the average wind speed of the wind. So let's scroll down a little bit, give myself some room here so I can solve this equation. And I got something to add here. What I want to add here is this equation, and now this is in the wrong place. I put this in the wrong place. This is with the wind. And this equation is into the wind, or the what's called a headwind. But these words relate to the wind. So to start solving this system of equations, it's pretty easy. I'm going to show you one way I like to do it. I'm going to take this equation here, the first equation. I'm going to write it down. And then to the right of it, I'll put the other equation, because I'm going to simplify these equations a little bit first. To simplify these equations, instead of distributing here, I'm going to divide both sides of the equation by 7. The reason I'm going to do that, because I know 7 is going to go into 2,800 very easily. It's going to go into it 400 times. The 7's on this side cancel out, leaving me with A minus W. Over here, I'm going to divide each side by 5.6. When I divide each of those sides by 5.6, that gives me 500. And that's going to be equal to A plus W. Now what I'm going to do is I'm going to combine these equations back into a system. I separated them for a minute so that I could simplify them. So I'm going to have 400 is equal to A minus W, and then I'm going to put below that 500 is equal to A plus W. Now I can use elimination. I can add these two equations together. 400 plus 500 is 900. And that's equal to A plus A is 2A, and these W's cancel out because they have the same coefficient with opposite signs. So I'm left with 900 is equal to 2A, so I divide each side by 2. When I do that, That gives me A is equal to 450. Now that I know A is equal to 450, this is the airplane's average speed. I can go back and solve for the average wind speed. Now I can use any of the equations, and I'm just going to use this one right here. 400 is equal, now I'm going to use this one, 500 is equal to A plus W. And substituting that in, we have 500 is equal to 450 plus W. We subtract 450 from each side. And that gives us W is equal to 50. So the wind speed here is 50. Final answer, airplane's average airspeed is 450 miles per hour, and the wind's average wind speed was 50 miles per hour. In example 4T, we're going to be talking about the break-even point. And the break-even point really has to do with profit. It's dealing with the profit equation, and that profit equation is this. I'm going to use words here to write it out. It's the profit is equal to the amount of income minus expenses. So as we read this problem, we're going to want to keep an eye out for things that be related to income, and things are going to be related to expenses. So suppose you have a typing service. You buy a personal computer for $1,750 on which to do your typing. You charge $5.50 per page for typing. Expenses are 50 cents per page for ink, paper, electricity, and other expenses. How many pages must you type to break even? We're being asked to find the break-even point. Let's define that real quick. The break-even point is when profit is equal to 0. So when the profit is equal to 0, so for profit we're going to put in 0 is equal to, now we got to figure out income, and we need to figure out something for expenses. Now, you buy a personal computer for $1,750. That's an expense. That's a one-time expense. That's a constant expense. So we're going to put that in here for our expenses, $1,750. We're going to subtract that from our income. Now it says here, and this might trick you a little bit, it says right here that expenses are 50 cents per page. Don't let that confuse you. Okay, even though that's an expense, we're going to subtract that from this income. We charge $5.50 per page for typing. Expenses are 50 cents per page for paper, ink, electricity, and other expenses. We actually, our profit or our income for per page is going to be $5. What we have to do here is we have to subtract 50 cents from $5.50. And the reason we need to do that is this is how much we charge, and this is our expense on that page. So after we subtract them, this is our profit, or this is how much money we make per page. This is our income per page. We have to subtract it from what we charge per page to figure out our income per page. And our income per page we're going to find by going 5 times any number, really. We'll just say, I don't know, say P for page. So to break even, we have to solve this equation. We know our profit is 0, and we have to figure out how many pages. So we solve this equation by adding 1,750 to each side. That gives us 1750 is equal to 5p. Then we divide each side by 5, and we end up with p being equal to 375. That'd be 375 pages to break even.